Good day, everyone. Welcome to Chapter 4 of the Cybersecurity Essentials 1.1 course. Alright, so we're looking at the act of protecting secrets. So we're going to look at access control, cryptography, and obscuring data. Let's start with cryptography. So cryptography is the science of making and breaking secret codes. Alright, so it's just a way to transmit information from one point to another point in such a way that only the person that the message is intended for would be able to read the message. So it's just a way of encrypting data such that the only the person you're sending the data will be able to decrypt the data. So there are several methods of creating ciphertext. So also understand that cipher is a series of well-defined steps used to encrypt and decrypt messages. So there's transposition, there's substitution, and one-time pad. So let's look at two types of encryption. So there are two classes of encryption algorithms: the symmetric algorithms and asymmetric algorithms. So you need to understand the major difference is that the symmetric algorithm uses the same pre-shared key, alright, also called the secret key pair, to encrypt and decrypt data. So which means both the sender and the receiver knows the pre-shared key before any encrypted communication would begin. The asymmetric algorithm uses one key to encrypt the data and a different key to decrypt the data. So one key is public and the other is private. So in a public key encryption system, any person can encrypt a message using the public key of the receiver of the message, and the receiver is the only person that can decrypt it that is using his private key. Alright, so which means that the receiver only shares his public key and gives the sender, so the sender uses the receiver's private key, public key rather, to encrypt a message, and after he has encrypted that message, only the receiver will be able to decrypt the message because only the receiver has the private key. So asymmetric algorithms are very complex. Let's really understand more about this private key encryption. So the symmetrical encryption process uses pre-shared key, right? Alright, so this pre-shared key is also known as a private key encryption, or the symmetrical encryption process is also known as a private key encryption. Alright, so there are some common standards that uses this symmetric encryption. So one of them is a 3Ds, right? The digital encryption standard. So um, this DES is a symmetric block cipher with 64-bit block size that uses 56-bit key. Right. So the 3Ds encrypt data 3 times and uses a different key for at least one of the three phases or one of the three passes among the three. Alright, so which will now give us a cumulative key size of about 112 to 164 bits. Then there's also the international data encryption algorithm, the IDEA. Alright, so it uses a 64-bit block and a 128-bit key. So it performs about 8 rounds of transformations on each of the system blocks that result from dividing each 64-bit block. So this IDEA is just a replacement for the 3Ds encryption system. Alright, so we also have the advanced encryption standard. Alright, so it has a fixed block size of 128 bits with a key size of 128 or 192 or 256 bits. So the National Institute of Standard and Technology (NIST) approved the AES algorithm in 2001 December. Now, for the public key encryption, which is the asymmetrical encryption process, remember I said it uses both a private key and a public key, and the private key is only known by the receiver, and well, the sender would have to use the public key of the receiver to encrypt a message. So a criminal cannot calculate the decryption key based on because he knows the encryption key and vice versa. So in any reasonable amount of time, the asymmetric algorithm, all right, it's very effective. So we have some types of asymmetric algorithm encryption processes. One is the reverse schema Adelman, all right. So the RSA, so it uses two very large prime numbers that are equal in length. So that's about 100 and 200 digits. So this is a method that browsers use to establish secure connections. And we also have Diffie-Hellman. So this one provides an electronic exchange method to share the secret key. All right. So we have the kind of systems or technologies that use this Diffie-Hellman encryption process are secure protocols like the SSL, the TLS, the SSH, and the IPsec. And we also have El-Gamal. So the US government uses a standard for signatures, and the algorithm is actually a free one. And we also have the elliptic curve cryptography. So it uses elliptic curves as part of the algorithm, and it's also used by the US National Security Agency. So let's compare these encryption process types a little bit more. So it's important to understand the difference between symmetric and asymmetric encryption process, which I said one uses a pre-shared key, which is symmetrical, and the asymmetrical uses both a private and a public key, and the private key is only known by the receiver. So you also need to know that symmetric encryption systems are much more efficient and can handle larger amount of data. All right. So, however, it can be cracked. So the key management with symmetric encryption system is more problematic and harder to manage. All right. But the asymmetric, on the other hand, is more efficient at protecting the confidentiality of small amounts of data, and its size and speed make it more secure and harder to crack. Then for the application aspects, all right. So one-time password or one-time password generating token is a hardware device that uses cryptography to generate a one-time password, and this one-time password is automatically changed after every uh, 30 seconds at least. All right, so the session password appears on a display and the user what enters the password. Authentication applications use this um, technology, right? So we also have the electronic payment industry that uses the 3Ds, or OS uses 3Ds to protect user files and system data with password, and most encrypting file systems such as the new technology file system use what the AES. So four protocols use asymmetric key algorithms. The IKE, which is the Internet Key Exchange, and it's a fundamental component of the IPsec VPN. Alright, we also have the SSL, which is a means of implementing cryptography into web browsers. Then we have the SSH, and SSH is a protocol that provides a secure remote access connection to network devices. Alright, so we want to have access to a server remotely, use SSH. Then you also have PGP, which is pretty good privacy, is a computer program that provides cryptographic privacy and authentication to increase the security of email communication. So we also VPN uses public network, right? And usually the internet uses the internet to provide a secure or create a secure communication channel. So a VPN connects two endpoints such as two remote office over the internet to perform the connection. So the VPN uses the internet protocol security, right? And the IPsec is a suite for protocol developed to achieve secure services over network. So the Protocol Security Service allow for authentication, integrity, access control, and confidentiality. So with IPsec, remote sites can exchange encrypted and verified information. So system memory holds data in use and it can contain sensitive data such as encryption key. So if criminals actually compromise the data that is in use, they will have to access they will have access to the data at rest and in motion. Remember, data at rest is data that is being stored probably on a hard drive, flash drive, right? Data that is not being used at the moment, and data in motion is data that is in transit, so data is being sent over the network. Now let's look at access control. Um, some types of access control is physical access control. So physical access control are physical hindrances or that are put in place to protect systems. All right, so they could be barriers, doors, all right, physical doors. So the goal is to prevent unauthorized users from gaining physical access into facilities, equipment, and other organizational assets. So physical access control determines who can enter or exit, when they can enter or when they can exit. So logical access control, right, is could be a hardware and software solution that is used to manage access to resources and systems. All right. So this technology based solutions include tools and protocols that computer systems use for identification, authentication, authorization, and accountability. So an example could be fingerprint or biometrics. And there's also administrative access controls. So administrative access controls are more like policies and procedures that are defined by a particular organization to implement or and enforce um, all aspects of controlling unauthorized access. So administrative control focus on personal and business practices. For example, the AWS organizations, you can implement IAM, all right, to control access to different AWS resources. So there are some access control strategies we look at. We have the mandatory access control. So this one restricts the actions that a subject can perform on an object. All right. So a subject can be a user or a process. An object can be a file, a port, or an I/O device. We also have discretionary access control. So the discretionary access control grants or restricts object access determined by the object owner. All right. So as the name implies, rather, uh, controls are discretionary because an object owner with certain access permissions can pass on those permissions to another subject. Then there's also role-based access control. So this one is based on role of the subject. So roles are job functions within organizations. All right. So for example, a manager would have higher privileges than a level one staff or an entry level staff or an intern. So specific roles require permissions to perform certain operations. All right. So users require permissions through their role. Then there is also the rule-based access control. So this uses access control lists to perform or to help determine whether to grant access or not. So a series of rules is contained in the access control list. So as shown, uh, as could be implemented in some organizations. So the determination of whether to grant access depends on the rules. For example, how long the person has been in a company, right? The particular group the user is part of. For example, companies could divide their workforces into different teams and groups. So different teams will have access to um, projects they are working on. So if you're working on a particular project or you're from a particular team, you will not have access to um, resources that other teams will have access to because they are working on a different project that uses those resources. So you only be restricted to the resources that are based on the projects that you're working on. Identification. So identification enforces the rules established by the authorizations policy. So a subject requests access to a system resource. So every time the subject requests access to the resource, the access control determines whether to grant or deny access. So cybersecurity policies determine which information identification control should be used. So the sensitivity of the information and of the information system determine how um, stringent the controls. All right. The increase in data breaches has forced many organizations to strengthen their identification controls. So now, even based on the identification controls, how do you authenticate uh, the, or like say, identifier? So how do you know, or how do you verify the subject? So there are three things that are mostly used, which is what you know, what you have, and who you are. So what you know could be password, passphrases, or pins. So these are examples of things that the user will know or the subject would know. Another thing that you have, that is what you have, could be your smart card or your security key fobs. All right. So these are things that will be supposed to be in the possession of only users. All right. And the last one is who you are. So this could be a unique feature, all right, or physical characteristics of the subject, which could be your biometrics. All right. So biometrics is either your fingerprint, retina scan, voice, or facial information. Then there's something called multi-factor authentication, MFA. So multi-factor authentication uses at least two of these methods for verification. All right. So an example is your ATM card, which is what you have. And before you can make use of ATM card, you also need to use what you know, right? So which is your password or your ATM pin. So authorization controls what a user can and cannot do on the network after successful authentication. So after a user proves his or her identity, the system checks to see what network resources the user can access and what the user can do with the resources. So authorization uses a set of attributes that describes the user's access to the network, and the system compares these attributes to the information contained within the authentication database. So it determines a set of restrictions for the user and delivers it to the local router where the user is connected to. So defining the authorization rule is the first step in controlling access. So an authorization policy establishes what these rules. Accountability. So accountability traces an action back to the person or process making the change to a system, collects this information and reports the user's data. So the organization can use this data for such purposes as auditing or billing. So the collected data might include the login time for a user, whether the user login was a source of failure, or what network resources the user was accessed. So that's exactly how AWS do their pricing. All right. So they have the log of what users use, the resources they use, how long they use it, at every point the resource was used. All right. So this allowed an organization to trace action, errors, and mistakes during an audit or investigation. So, for example, what if there was a data breach? So it is this log that is being reviewed to investigate theft or investigate um, vulnerabilities. Now, implementing accountability consists of technologies, policies, procedures, and education. So, log files provide detailed information based on the parameters chosen. So, let's look at types of security controls. There's preventative controls. So, prevent means to keep something from happening. Alright, preventative access control stop unwanted or unauthorized activity from happening. Then deterrent controls. A deterrent is the opposite of a reward. So a reward encourages individuals to do the right thing, while a deterrent discourages them from doing the wrong thing. So cybersecurity professionals and organizations use deterrents to limit or mitigate an action or behavior. So deterrents do not always stop these actions. Then there's detective control. So detection is the act or process of noticing or discovering something. So access control detections identify different types of unauthorized activity. Detection systems can be very simple, such as a motion detector or security guard. So they can be more complex, such as intrusion detection systems. So there's also corrective control. So corrective counteracts something that is undesirable. So organizations put corrective access controls in place after a system experiences a threat. So corrective control restores the system back to a state of confidentiality, integrity, and availability, which is the CIA triad. So they can also restore systems to normal after unauthorized activity occurs. Then there's recovery control. Recovery is a return to a normal state. So recovery access control restore resources, functions, and compatibilities after a violation of a security policy. Recovery control can repair damage in addition to stopping any further damage. So these controls have more advanced capabilities over corrective access control. Then there's compensative control. Compensate means to make up for something, right? And compensative access control provides options to other controls to bolster enforcement in support of a security policy. Because compensative control can also be a substitution used in place of a control that is not possible under any circumstance. Now let's look at obscuring data. So data masking is a technology that uses or that secures data by replacing sensitive information with a non-sensitive version. So a non-sensitive version looks and acts like the original. So this means that a business process can use non-sensitive data, and there is no need to change the supporting applications or data storage facilities. So in most common use cases, masking limits the propagation of sensitive data within IT systems by distributing surrogate data sets for testing and analysis. Now, data masking techniques could be by substitution or by shuffling. So, substitution has to do with replacing the data with authentic looking values to apply anonymity to the data records. So, there was a time in Nigeria when cryptocurrency transactions were banned, right? And how the banks would know that it's a cryptocurrency transaction is because of the fractions that are within the transfers, right? So, and not just the fractions, the also the narration, all right? So if you have anything crypto related to your narration or reason for sending or making a transfer, the bank is going to flag your account, right? So now, how did but yet crypto transactions were still done. So what people did was that they got rid of the fractions, right? So made all the transfers to be rounded figures and substituted the narration. So instead of having things like uh, Bitcoin transfer as your narration, you put things like Gary deal, beans, all right, tomato paste, all right. So you substitute. That's substitution. Then shuffling. So shuffling derives a substitution set from the same column of data that a user wants to mask. So this technique works well for financial information in a test database. Now let's look at steganography. Steganography is concealing data inside another file. Alright, so the advantage of steganography over cryptography is that the secret message does not attract any special attention. So no one will ever know that a picture actually contained the secret message by viewing the file either electronically or in hard copy. So there are several components involved in hiding data. So there is embedded data, which is the secret message, the cover text or cover image or cover audio. So this cover item hides the embedded data, producing the stego text or stego image or the stego audio. So a stego key controls the hiding process. Now there's something called data obfuscation. All right, so data obfuscation is the use and practice of data masking and steganography in the cybersecurity landscape. All right, so it's the art of what obscuring data. All right, it's the art of making the message confusing, ambiguous, or harder to understand. So a system may purposely scramble message to prevent unauthorized access to sensitive information. So software watermarking protects software from unauthorized access and modification. So the secret message is the software watermark, for example, that is used in softwares. So comes an end of this chapter. Understood um, the what cryptography is. All right, the principles of cryptology that is being used towards secure communication, and I explained the difference between symmetric and asymmetric encryption algorithms, right? And we also explained access control and what it means to obscure data. All right, so we've come to the end of this chapter. See you in chapter 5.